we're doing the 3 C's for the start of our prototype, and those stand for what? Camera, control, and character. So we kind of have a character under user control. What part haven't we done yet? Camera. So we need some basic camera going in here in order to flesh out our RPG/action / tactical RPG project. I'm going to not cheat, but I'm going to, in order to save a bit of time, we're going to look at an asset that's already available to us. If you go to assets and go to import package, in Unity 5.4 there are some default packages that we can use to get our projects up and running quickly. There's a package called cameras, there's a package called characters. I'm actually going to use for the camera a script in the characters package. So I'm going to click on characters, and you're going to see everything selected. We can see what's in this package. There's all kinds of stuff for first-person shooter and ball controls, and there's some sound effects in there, some AI stuff. Maybe we'll look at that. But really, all we want is this one script called smoothfollow.cs. So I'm going to hit none, and I'm only going to import smoothfollow.cs, and I'm going to say import. So we don't have to take everything from a project. Remember last semester, I had you make packages of everything, and I would import everything. And that usually worked as long as you weren't using tags, and because you have to give me your tag manager asset. I'm just showing here that we don't have to import everything necessarily. We only have to take the one. Question? No. Okay. So we should now, under standard assets, have under utility, smooth follow. And this actually is implemented very similarly to the 3D camera we did last term. When we expand on the camera later in the course, later in our project, we'll go back to this and we'll flesh this out to do exactly what we need to in different game modes. The camera's going to do different stuff, but it gets us up and running quick. All we have to do is click on our camera entity and specialize its behavior by associating that script. I drag and dropped it, and it's got 5 parameters. A transform that it tracks, a parameter for distance and height, and a couple extra parameters that control how fast it tracks the height and orientation. This camera is going to try and get behind the transform referenced in the transform field there. How does it know it's behind? Because if you know where the forward is, and the forward is always in front, you go to negative forward and you're going to be behind. What's the thing we want to track? Let's track the hero. Drag and drop that. And just to start, we're going to give it 5 and 5 and 1 and 1. And we're going to hit play. There we go. Now if we go to full screen, just to see what's happening, I'm turning to the left. The camera is following me. If I let go, it rotates back again. We actually can't tell because I'm full screen. Maybe we need to preview this. Maybe we need to see in the scene view just to show this is working. Let's go. Let's go to here. Zoom in on the camera. Press F. And now under user control, we can see the camera's rotating with us. I stop rotating, the camera's going to catch up. Similarly, I go there, the camera's going to catch up, and I can walk around. If you want to go a little bit further away, we can tweak out distance. If you want to change the height, we can do that too, if you want to be even further behind him. If you make these dampening values bigger or smaller, what's the effect on the behavior of the camera?
How fast it reacts to the player's motion.
Right. So does a bigger number make you react faster or slower?
Slower. Bigger number means slower.
Right. Slower number means tighter, bigger number means slower. All right. So we're going to run with that for our default camera for now. What's next? We've got some 3Cs kind of in place. How can we make this a little bit better? Let's add some character animation. Very good. What's the best website in the world for that? Mixamo. So let's go there. Okay, here we are back again. We're going to add some character animation to our project, and we remember that the best website for this is Mixamo, here we go, mixamo.com. We all have access to this because it comes with the Creative Commons license that we all get. I'm logged in right now. If you're not logged in, please do so. And remember right away, we can click Browse Animations to see what's available. It may have changed a little bit since the last time you looked. The last time I looked, there weren't as many of these packs of animations. I remember we had to go in and sort of grab them individually. But now we may not have to do that. So I'll leave it up to you. For locomotion, we want to start with some motion controls. We can use male or female motion pack. We can use magic motion pack, or probably scary zombie would work too. What do you want to do? Pro sword. Is there motion in here? Let's see. Oh, there we go. So he's got navigation in there. We'll change the character from Malcolm to the knight, and we'll see if that helps us. I'll click on change characters. We'll take paladin with prop. That makes sense since we're doing an RPG. Here he goes. Nice, got some strafe in there. Walk backwards. Turn 180. And the nice thing is that because those things are attached as props to the body, we'll be able to detach them, and maybe we'll be able to use them for our objects when we do interactive objects. Nice little block. All right, so let's do that. View download. I like it. There's 51 animations in there. Let's just grab it. And there's every single individual animation. One of these things should be like called motion pack, and it'll be a zip file with everything in it. Maybe it's under tab number 2. Pro sword and shield pack. There we go. Yeah. We can customize all these anims if we want to. Let's save that for another day. We remember that from last term. I'm just going to click Q download. FBX, T-pose, 30 frames a second, no reduction, and hit Q download. And it's only 11 megs? Wow. So there we go. Once we have a zip file, we're going to show it in folder. We're going to right click. We're going to say extract to a folder with the same name, which is here. And then to import that into our game, we're going to use the default art asset import pipeline. Drag and drop it. It kind of rolls off the tongue at this point. If it complains and says some of your textures are wrong, you should fix them. Please feel free to do so. And we've got a nice little folder called Pro Sword in our project. If we zoom this little widget thing to the left, we've got an import node for every single animation, and there should be a version of this in the T-pose right there, which is what our guide looks like. So in the bottom right hand corner, we can see that that's nice. Okay, our character is going to be this guy in the T-pose, but in order to animate this properly, we need to do something right off the bat with the import options. Remember this from last term?
Change it from generic to humanoid?
Correct. We will be using the IK system. I don't know that we did that last term. I think I talked about it last term. But we'll definitely be using inverse kinematics in order to encode, tweak out what the hands and the feet and the head are doing when we start to interact with props. Because rather than play an animation that just precisely gets your hand to the target, we're going to be able to do that with some math and do some 3D calculations for these kinds of things when we're interacting with stuff. So we're to facilitate that, we're going to change the rig to humanoid. And just as we did last term, it's a good habit. So you click on the import options under rig, change everything to humanoid, and hit apply. And it's going to think for a while. And it's thinking. It is thinking. There it goes. I blame Windows. I had to click something for it to work. Okay, are we back? We're back. Everything's humanoid nicely. Okay, so let's add a game object for our model for our character. So we'll use Paladin with prop J Nordstrom. I guess that's the author of it. We'll create an instance of that. How do we do that? Drag and drop that into the scene, and we should see right away. There he is. He's a little bit low, so we'll raise him up a bit. And he's in his T-pose already. I'm gonna set the height to 0.5 for that height. And because I want to use the character controls that we've already built for hero, I'm gonna make this a child asset of hero. Okay. We don't need the hat anymore, so I'm going to turn off the hat's renderer. We'll leave the object there in case we need to debug something. Similarly, I'm going to leave the mesh renderer on the capsule, but I'm going to disable it. And there we have a guy in T-pose. If we click on him and zoom in a bit, let's just see that it looks good. What do you think?
Yeah.
So far so good? I like it. It's got a helmet and stuff. We'll see that, there's some parts there, so if we disable the helmet, he's actually got a face under there. So maybe we'll use the helmet when we start to do enchanted objects. Same for the sword and the shield. There and there. Okay. What's next? If we press play, with any luck, we'll be able to use the same navigation system and translate our guy around the world. So yes, we're still under character control, user control. So very nice. What's next? I heard let's make him animate, and I would tend to agree. Let's do that. So we're gonna make the character animate. How should we do that? We're gonna need an animator, right? So to start, let's get him idling and get him walking. We'll review how to do animation state transitions for that, and then we'll revisit some of the more complicated animation concepts like blending and blend trees and layers as we do more sophisticated things on the character. So as we add more moves to the character, we'll see that we have to add more complicated animation stuff. But for simple navigation with what we've done, all we need is two states. Idle and walk. So we'll do it in hero control. I think that's a sensible place. We've already got that script there. But we're gonna need an animator, right? Turns out if we click on the animation, the skinned mesh, we've already got an animator component there, but he doesn't have a controller. What's the animator controller again? Do we remember what that is? This thing. It is. It's the container for the state diagram, for the state machine of the animation system. So this object is this animator controller is where those nodes and those connections live. We have to make a new asset of that type. So we'll create it. We'll call the hero anim controller. Okay. And we'll associate that with the animator by drag and dropping it there. And then we see that the information changes in the animator. It tells us how many clips are in this state, et cetera, et cetera, et cetera. If we wanted to have a different state machine for this guy, we could make a different animator controller with different anims connected, and that's how we could change it on the fly. We'll actually see other ways of changing animation on the behavior on the fly with override controllers. Once we start to do interactive objects and equipable objects, we'll see that even objects can influence how characters animate. All right. So let's populate this animation FSM with some interesting stuff. How do we do that? Bless you. you go to the animator window, that would be correct. And we need to add a couple anims. Where's those anims again? Where did we import all that stuff? Is it in utility? Where did it go? It's in utility, okay. So it went into utility, ProSword, etc., etc. So we're gonna need a couple anims. We're gonna need an idle and a walk. So sword and shield idle. We've actually got a few of them. We've got idle 1, 0, 1, 2, and 3. If we go down into them and click on the animation asset named Mixamo.com because we borrowed it from Mixamo, we can see the behavior. So number 1, he's kind of turning left and right. Number 2, he's kind of stretching his neck a little bit, maybe his arm, something like that. Number 3, something different there. Why do you think they gave us 4 different idols?
Just to make it a little bit more realistic.
Yeah, it's very common when you enter a state to have multiple animations for that state, and then you pick one randomly, and it adds a little more variety. We will look at that as a second pass to what we're doing right now. So we'll pick one. We'll take idle 1. We're going to change the name of it. We're going to call it idle 1, idle 0, because we're using 0-based stuff. And we'll hit apply. We can add the idle animation to our controller just by doing that. Now if we go back to our scene and zoom in just a little bit, we should see our guy idle right away as soon as we hit play. And he does. Nice. Oh, but what happened? Didn't loop. We forgot to do that. So we click loop time, loop pose, hit apply again. Now we should loop correctly. We forgot something else too. In terms of navigation. We are going to connect it to a walk state. We'll have these two items going to one another. But what is the thing that actually, go ahead. We might need to do that. We'll when we see him animating, we'll check if we need to. What actually is going to translate our character? What decision did we make? Remember, there were 2 types of animating a character under root motion or not, and we decided we're going to use not root motion. So in our animator, because we're translating the hero capsule directly in our animator, we're going to disable the apply root motion checkbox. So even though there may be root motion in the animation, we're going to ignore it for now. Okay? So now going back to the animator, the second state we're going to need is some kind of walking. Question?
Can you just repeat that thing you were talking about?
Sure.
Glad about it.
So we're actually moving the capsule in code, right? In our hero control script. We did that, wrote this code here to manually move the transform and manually rotate the transform, right? And we're making the animated model a child asset of this transform that's moving under code control. Last semester, we looked at 2 ways of moving a game object that's playing an animation, right? A character model can have animation move its transform and rotate its transform, or it cannot, and that's root motion or in place motion. So because we're deciding to make this design decision, we're going to disable root motion, and we're just going to animate him in place while he's a child of this capsule, and we'll see if that's enough. We might find that that's okay for our game. We might find that it's not, but for taking this iterative approach to developing systems, we're going to start with in place, and then we're going to decide. Okay? All right, so that's why we disable the root motion checkbox on the model right there. Okay. Going back to our animation collection, what walk are we going to use? We got walk and we got walk 1. What do you think? Walk 1 is backwards. We won't use that to start. Walk is forward. So let's use that. Go back there. We'll call this walk forward. We need to make it looping because walk anims are looping. So we'll loop pose and we'll lose time. Pardon me, loop time, and we'll hit apply. Then we'll take that walk forward animation, drag and drop it into the thing. Now we need to connect these two animations together, right? In order to transition between walk and idle. We looked at a few different ways of doing that last term. There's ways of doing it that are more code driven. There's ways of doing it that are more FSM driven. What's probably the easiest way? We could do a blend tree, so you could take like a percentage of the idle and a percentage of the walk, and we could go between one and the other. I think there's even an easier way, and that would be that would just be a state transition. So when a condition occurs, we're gonna go from this anim to this anim over this amount of time. And the way we do that is by making a transition. So we right click, we say make transition, and we click from the idle to the walk. And so now we've got a transition from idle to walk. And how do we set the condition that dictates when to do this transition? Just single click on the arrow. And we see, now we get this editor that shows us a way of previewing what the anim looks like, and then the transition from state 1 to state 2. And the transition starts where the first blue transition arrow is, and it goes over the duration of this blue space to the second blue transition arrow. So you can control how fast that transition occurs, but it's either going to be playing one anim or the other. Never like a combination of the two, except during the transition. We're going from A to B. What's the condition? What will the condition be in our game? To make this under user control, what would be a sensible way, what would be a sensible thing to check? Should we change from idle to walk? When the user does what?
We should check if the axis is being used.
That's right, I heard it from a few different places. If there's some vertical axis component that's like greater than, kind of a little bit greater than 0, then he's probably pushing up on the stick, which means probably walk, right? And if he's not pushing on the axis, it means probably it's idle. So we're going to need a way to know that. How do we know that? How can we communicate from our animation FSM with the script? Because we need to glue those together. We do. We need parameters, right? We need parameters in our animation FSM. How do we do that? We click on parameters, and then in this little plus thing here, it may look a little different from where the last time we used it. And Unity likes to change the UI all the time. And we've got 4 types of parameters. Let's make it a float, and then we'll pass the axis value straight into the animator, and then we'll make that comparison in the animator. Okay? So we'll call that V for our vertical value. We'll add another parameter while we're here. We'll call it H. That'll be for the horizontal axis value. So we're going to check. Our transition is going to happen from idle to walk when, I think we said it before, when the vertical value is greater than some amount. And we know that the axis what's the range of axis data off of a joystick? -1 to 1. Right? Because the axis can either be full left or full right, or full up or full down. So we're going to say if it's greater than 0.1, do the transition. So if the stick is pushed 10%, we're going to do that. And then similarly, to go back, we're going to decide to go back when V is less than. And it's good to not use the same constant, especially if it's a floating point value. Just in general in computer science, it's really good not to compare the same float all the time, especially when you're dealing with electrical devices like an analog joystick, because there may be differences in the electrical state of the device. We want to give it a little bit of a dead zone, and so we're going to use 0.09 to give us that little bit of empty space to make it really deliberate. Yeah, I know I've let go of the stick. So between 0.09 and 1, there's not going to be any stage transitions. But if you're greater than 0.1 or less than 0.09, there is. Okay. So now we can preview this. We can see if this is actually working. Let's do it by actually going through and changing the value of our parameter, we see that he transitioned to walk, and if we want him to transition back again, we'll go back to 0. It seems to be working, but what do you notice?
On 0, it's going back to idle.
Which is good, right? Because this corresponds to us letting go of the stick. We want to go back to idle. But what do you notice about how responsive the state transitions are? Like if I do this right now, now he's transitioned.
Letting it complete.
Yeah, it's waiting till the animation actually literally finishes before the transition occurs. Is that what we want for navigation? No, it is not. And sometimes we do. Sometimes you want a transition to happen at a certain point in an anim. If the anim is like a one-off special move, like an attack or a jump or something. But for navigation, we want it to be really responsive. And the reason it's waiting is because we see here in our transition editor, we're actually waiting for like 3.5 seconds before the end for the transition to start. So if you hit the button, if you hit the stick just here in the loop, it would wait until the very end. The way we can make the transition happen anytime is by doing what? Remove that exit time. So it will still do the transition over this amount of time, but it will happen as soon as the condition is evaluated to be true. And we remember that from last semester. So we hit Control S, and we preview that again by pressing play, and then we go into our parameter and we hit 1, and he's going to start walking right away. And when we go back to 0, he goes back to idle. All right. Questions? So far, so good.